So we have mentioned that we have assignments that doesn't count, okay? And what's more is the assignment questions, if you see it, then it also means that you won't see those questions in your exam. So we are not going to use the same questions from the assignment. We are not selecting the assignment question and then choose them to be included in the exam. What we really hope is that the assignment questions are going to train your mind, your understanding about the topic. And then if you can understand the topic well, then you can solve the problems in the exam. Is that okay? So this is usually our design. So we are going to give you very challenging assignment questions, but also interesting, okay? So for instance, we are going to talk about logic. And then logic, there are lots of puzzles. So there are logic puzzles. So you will see that in the assignment, but probably you won't see them in the exam, okay? So some famous logic puzzle is something like this, okay? You have this, there is a question is like send more money, okay? So there is a puzzle that looks like this. You want to represent, so you want to find what? You want to find for each symbol a number from 1 to 0, 0, 1, 2, 3 up to 9 to represent them. Different English character represent different digits, okay? So S should be different from E, and then we want to find a way such that this becomes correct, okay? Okay. So for this question, maybe the first task that we want is we want to use some clever way such that we can find out some digits and then discover one by one. And then, so we want to find one set of solution. This is good, okay? If you can find a solution, this is good. And the more challenging part is that can you show that your solution is the only solution to this problem, okay? Or maybe on the other hand, maybe you want to show that for this problem there can't be any solution. Usually there can't be any solution is the hardest one, because how can you show that there can't be any unless you tried all of the possibilities, right? So but in logic the key point is that we want to use some reasoning so that you can still argue there is only one solution or there is no solution by using as few sentences as possible. You don't want to say that I have tried all the, how many? I don't know, maybe n factorial combinations of the choice here, and then none of them works. Okay, good. So, but this is a very long proof, and it probably relies on computer to help. But on the other hand, if you are solving logic puzzles of this scale, maybe you want to have something written down so that a normal person can understand. Okay, so this is one. Okay, now, yeah, this is I guess this is included in your assignment 1 question. Okay, and there are a lot of logic puzzles. Oh, okay, we will talk about logic, but before that, let me ask you this one. This is something I've heard about it a long time ago. So you have, okay, so you have a lot of people standing in a line. So one is taller than the other, and so on and so forth. Okay, so this is the shortest one. Okay, and then all facing this direction. So they are facing this direction. Okay, every one of them has a hat. Has a hat. They have a hat. Okay, so let's say there is someone who is giving one of them, every one of them a hat. Give it here, and then here, and then here, and so on and so forth. The hats can be black or white in color, just these two. Let's say there are, okay, how long is it? Let's say there are 20 people around here. Okay, let's say there are 20 people lining up. So they want to, okay, so every one of them, okay, actually, this group of people, they want to make, so we will ask this person, what is the color of your hat? And after that, we will ask the next person in this line, what is the color of the hat? And so on and so forth. we hope that as many of them can answer correctly as possible. Okay. Okay. Is that so all these people, they are actually working as a team. Okay. As long as the best case is what? All the 20 questions are answered correctly, right? Of course, the worst case is all of them are wrong. Okay. Is there a way that we call it maximize? We can make the number of correct guesses as many as possible. And if so, what is the number of correct guesses we can guarantee? So these people can work together so they can form a plan. Okay, if you are saying this, then I am saying this. If you are saying this, I am saying this, something like this. Okay, is there a way to do so that guarantees the maximum number of correct guesses? Okay, I give you one solution. Okay, this solution is easy. Everyone guess the hat randomly. Okay, yeah, either black or white. Okay, so I say black. Okay, the next one, white, then black, white. But this method does not guarantee anything, because in the very worst case, we call it the worst scenario, the very bad scenario. Okay, then nobody is going to answer correctly. Okay, I give you another one. This time, okay, they form pairs. So there are 20. They form 10 groups. Okay, so this one is saying the color of this one, and this one repeats. Is that okay? And this one is saying the color of this one, and this one repeats. Okay. Okay. So if I'm the last person, I won't be guessing my hat at all. Because I can see the one in front of me, I'm saying his color. Okay, I sacrifice myself. I don't care whether I'm guessing correctly. But then this one is guaranteed to guess correctly, right? So this is a different scheme, but this time this scheme can make sure that at least 10 answers are correct. Why at least? Because maybe you are lucky. Okay, maybe these two are having the same color. So maybe you are guessing more than 10 correctly. But of course, in the very worst situation, then only 10 of them can guess correctly. Okay, but in any case, we know that the maximum number of guesses cannot exceed 19. You cannot have 20 correct guesses guaranteed. No way, because the last one can never tell what is the color of the hat, right? Okay, whatever he say, I can create a scenario that makes your guess wrong. So 19 is the maximum possible, but we don't know how to do that. But at least we know that the best scheme can ensure at least 10. And then what is the number that we can guarantee for our scheme? What do you think? Anyone has heard of this question before? If you have heard of this one before, could you please raise your hand? Hey, nobody? That's great. Yes. Okay. What do you think? What do you think? Yeah. Okay. I'll tell you. Amazingly, we can guarantee 19 correct guesses. Now, this is super amazing, right? 19. 19 is the best possible. But what kind of scheme can guarantee 19? Okay, now for this one, this is a puzzle, and to solve a puzzle like this, we don't consider n is equal to 20 of this scale, too large. Okay, so let's try. If there are 2 persons or there are 3 persons, can we do something like this? For 2 persons, can I make sure 1 or more? Yes, 2 persons, I can ensure 1 or more. 3 persons, is there a way that I can ensure 2? It seems difficult, right? Yeah, so here they have 3 hats. Yeah, how can I ensure 2? It means that this one says something. Okay, he says the color of my hat is black, let's say, and this one must be able to answer correctly. And using the information received so far, this one has to answer correctly again. So they cannot just form groups of 2. they are forming something even more challenging, right? So for actually, right? Yeah, groups of 2, then the answer of this one and this one may not be related. But here, the answer of this one and the answer of this one and the answer of this one, all of them are related to the answer of this one, right? To the color of this one. Is there a way to do so? Okay. Let me see. Yeah. Coco, you know the answer, right? You don't know? Okay, good. Okay.
Could the person say something else or waving his hands?
No, he cannot. So they cannot use any other communications like delay in the answering or the movement or shaking or making an earthquake. Yeah, they cannot. Yes, okay. Yeah, good question. Okay. Okay, let us keep this question for a moment. Maybe something in the course material will help you answer this question. Okay? Okay, so we are going to talk about for logic. So we are talking about logic now, the introduction to logic. And then logic is something that helps us to understand what is correct and what is wrong. What is, we call it true, what is true and what is false. True, it is a true thing that we should believe it all the time. A false thing is something that is wrong and we should not believe it. And then there is a keyword here called proposition. And then once we have defined proposition, we will talk about proposition logic today. Okay. So what is a proposition? Proposition comes from the word propose, right? Yeah, so what is propose? Okay. Propose, of course, yeah. Propose, 2 persons, one propose to the other, will you marry me? Okay, yes or no. So this is a propose. Propose this is just a very thin scenario. Okay, so in a broader sense, propose is I'm claiming something. I want you to believe me, or I have something that I want to tell you. But then the things that I'm going to tell you may be correct or may be wrong. But in any case, it is only one of these two options. Okay, either yes or no, either true or false. So propose is I'm going to propose some statement to you, and then you decide. Okay, so in logic or in mathematics, a proposition. So this is what is a proposition. So we have a definition of it. So it is a sentence, a declarative sentence. We are declaring something. A declarative sentence let me define something first. Okay, before we, so I need to define what is a declarative sentence. A declarative sentence is a sentence that declares a fact. A fact. So what is an example? Okay, what are examples of declarative sentence? For instance, 1 + 1 is equal to 2. So this is a declarative sentence. So I'm declaring, I'm saying that 1 + 1 is equal to 2. Okay? Okay, another declarative sentence. 2 + 2 is equal to 3. Okay? I'm declaring, I'm saying that 2 + 2 is equal to 3. So this is a declarative sentence. Okay, a declarative sentence doesn't mean that it has to be correct or what. As long as it is declaring something, then it is a declarative sentence. But on the other hand, a question is not a declarative sentence. For instance, I'm asking, what time is it? So it is not declaring anything. Okay, I'm asking you something. It's not declaring. Or read this carefully. Read this note carefully. So I'm commanding you to do something. So this is not declaring things. Okay. So I hope you understand that declarative sentence always relate to a fact. But then this fact, this sentence, or the meaning of this sentence could be correct or could be wrong. Okay? Now, based on declarative sentence, using the board here, then we can talk about what is a proposition. So a proposition is a declarative sentence that is either true, this is something that is true or correct, or false. False is either correct or wrong, but not both. Okay, it's strange. Okay, it's strange, but let's see. For instance, 1 plus 1 is equal to 2. Then this is a proposition. This is, first of all, this is a declarative sentence, right? And then you know that 1 plus 1 is equal to 2. So this is a true declarative sentence. So we call it a proposition. Okay? 2 plus 2 is equal to 3, then it is also a proposition. But this time it is a false declarative sentence, a false proposition. Okay, so what are things that can be either true or false and both? Okay, for instance, x plus 1 is equal to 2. Okay, what is x? I didn't tell you. X could be 1, then in that case, true. X could be 2, in that case, wrong. So in that case, this is not a proposition, but this is a declarative sentence. Okay? Okay, and then, okay, last one, I have an example here. You will pass in this course. Okay, is it a declarative sentence? Yes, it's a fact. I'm declaring that you will pass in this course. Is it true? I don't know. Okay. Yes, okay, good. You have confidence. That's good. Or is it false? We don't know. But this is still, for me, I could still consider it a proposition. Because you can't pass and fail of this course at the same time. Okay, it must be either one of these cases. It is just I don't know at this moment. Okay, but eventually you will be passing this course or not. Okay, so eventually at the last moment, this is going to be a proposition. Is that okay? Although I don't know. Okay, so proposition doesn't mean that we have to know the true or the false value of this proposition by ourselves. As long as it just have either true or false, but not both, then this is a proposition. Is that okay? So for instance, in mathematics, there are a lot of propositions that nobody can tell whether it is true or false. Especially, there are many propositions coming from numbers, number theory. So we have talked about primes so far, right? Okay, now let's pick a number, even number, let's say 4, okay? Now 4 can be written as the summation of 2 primes, 2 plus 2. Is that okay? 6, you can also write it down as the summation of 2 primes, 3 plus 3. Is that okay? And then 8. 8 you can write it down as 3 plus 5. Okay, 10. 10 you have more options, 3 plus 7 or 5 plus 5. Is that okay? And then 12, 5 plus 7, 14, 7 plus 7, 16, 16, yeah, 5 or 3 plus 13 or 5 plus, okay, and then 18, so 18, 7 plus 11, or there can be other options. Is that okay? Now it seems that for all the even numbers, looking at this trend, you can express this as a sum of 2 primes. So there is a proposition. So someone has made this proposition. This proposition is any even number greater than or equal to 4 can be written as a sum of two primes. Okay, as a sum of two primes. Now this is a proposition. This is a proposition. Either it is true, okay, or it is true. Really, every possible even numbers greater than or equal to 4, you can always find two primes that adds up to that number. Okay, it is a very strong proposition. It says every even number. Or it could be false. Maybe you can find out some even number that no matter how you divide it into two parts, at least one part is not a prime. Okay? So we know that this is a proposition, but nobody at this moment can tell whether this is true or false. And this proposition has a name. Okay? So some proposition that we don't know whether it is true or false, we usually call it as a conjecture. So a conjecture is, I think this proposition is true, but I cannot tell what is true or false actually. A conjecture, I guess, a conjecture. And this conjecture is raised by this person called Goldbach. So Goldbach is a Russian mathematician or someone who works in Russia, okay? Yeah. So Goldbach's conjecture, and it is one of the well-known unsolved problem in number theory. Nobody knows. It's a proposition. We don't know the true or false value. Okay? Okay. So this is a proposition. 1 plus 1 is equal to 2. It's a proposition. Okay? Or you will pass this course. Okay. Now proposition is some discrete thing. So this is a sentence, right? This is a sentence. So as long as it is some discrete things, we can we can use a variable to represent it. Maybe you can let the little character p to refer to this sentence. So whenever I want to talk about this sentence, I can use p. Is that okay? So we may let p to be the proposition of this one, or we can use q to represent this sentence. Is that okay? So it's like what? Like when we are doing algebra, we're using x to represent a certain kind of number. Here we're using p or we're using q, but this time it represents a sentence. So when we talk about p, then this means this sentence if we are defining this like this. Okay? So this is a variable that is representing a proposition, so we call this a propositional variable. It's just a name like this. Okay. And then we can also talk about, this is a new concept, but a very easy to understand concept. So truth value. So for each proposition, it is either true or false, right? If it is true, then we say that the truth value is true. If it is false, then the truth value is false. Is that okay? So for this sentence, 1 plus 1 is equal to true, then we have the truth value of this one is this one, the truth value of this one is true. Okay? And sometimes we use a short form, t, to represent it. Now for this one, I don't know, okay? So, but let's, yeah, I don't know yet, okay. Let's say r is, this time it represents 1 plus 1 is equal to 3 this time. Now for this r, then we know the truth value of this one is false, F-A-L-S-E. And then we usually use the symbol F to represent it. Is that okay? Okay. And next, let me talk about some, I call it logical operator. operator. So operator is something that works on a proposition or a number of propositions to create another one. Okay, so the first operator that I want to talk about is the negation operator. So these are really simple things, so don't worry. I'm using, so the negation operator. So if you have a proposition P, then I can create a new proposition. So the negation operator looks like this. Okay, so I can create a new, can you see this? Okay. So you have a P. Okay, so we talk about the negation operator. You can create a new proposition by negating it. Okay. So this is the negation operator. So this proposition is related to this one. Whenever this is true, then this is false. Whenever this is false, this is true. Is that okay? If you have a proposition like this, then we call this is the negation of that proposition. Okay, I'm talking about things very strange, but it is easy. So for instance, 1 plus 1 equals to 2. This is a proposition. Okay, I don't know whether it is true or false, but I can create something that whenever this is true, then the new proposition will be false. And whenever this is false, the new proposition will be true. So what can I do? Okay, so let's say P is equal to 1 plus 1 is equal to 2. Then negation of P can be something like 1 plus 1 is not equal to 2. Do you understand my point? Now these two propositions, they have very interesting behavior. I don't know whether 1 plus 1 is equal to 2 or not, but if it is true, then 1 plus 1 not equal to 2 will have the opposite truth value. Okay, so this is the negation. Okay, so let's try English. Okay, so suppose that I have a sentence or a proposition like Simon's PC runs Windows XP. Okay, an old one. Okay, I don't know why he's still using Windows XP. Maybe for some old reason. Okay, now Simon's PC runs Windows XP. This is a proposition. Is there a way? I don't know. Okay, I'm not that close with Simon, so I don't know whether his PC runs Windows XP. But still, this is a proposition. I want to make another one so that they are always going opposite. So what should I do? So Simon's PC runs Windows XP. So the negation of this one, the opposite of this one is what?
Simon's PC does not run.
Very good. So very good. Yeah. Simon's PC does not run Windows XP. So even if I don't know who is Simon, but I still know that these two propositions, one is the opposite of the other. So this is what is meant by negation. Okay. This one. This one is a little bit tricky. Okay, so let's say Kirker's PC this time. Okay, Kirker's PC has at least 36 gigabytes of memory. Very small nowadays. Okay, but at least. Okay, at least. So Kirker's PC has at least 32 gigabytes of memory. So what is the opposite of this one? Less than. Very good. Okay, good. Okay, of course you can say Kirker's PC doesn't have at least 32 gigabytes of memory. Okay, this is good. But a more natural way is Kirker's PC has less than. Okay, at least less than. Okay, very good. At most is not, because yeah, very good. Less than. Okay, strictly less than. Okay, so you understand. Okay, so here, whenever you give me a proposition, I don't know whether it is true or false. I still can tell there is a proposition that is opposite to it. And then we can denote it using this negation. Okay, P and the negation of P. Okay? And now, apart from negation, we have something called conjunction. Conjunction means something that is together. This is and. it reads n as n. So I have proposition P, I have a proposition Q. I have two different propositions, but I can create a new one. I call it P and Q. So what does it mean? Okay, P and Q will be true only when both of them are true. Otherwise, it is false. So and means together. If together they are true, then altogether it will be true. Is that okay? Okay. So test your understanding again. Okay. For instance, let's say there are two propositions. One is Kai is the lecturer of this course. Okay, this is one proposition. And the other one is this course is held on Monday and Friday. So we have two propositions. And of course, by this time, you know that what is the truth value of these two ones, right? So the first one, Kai is the lecturer of this course. Is it true or is it false? True. Very good. Okay. The course, okay, this course is held on Monday and Friday. Is it true or is it false? False. So how about the and of them, the conjunction of them? False. Very good. That's it. Okay. Okay. Easy. Okay. Now, so this reads as and. It looks like A. It looks like the English character A, right? So together and. So and. Okay. Now, something that is similar, we call it the disjunction. Disjunction is I have a P, I have a Q, and then I have P. This is reads as or, P or Q. So whenever at least one of them is true, then this is going to be true. Or. So it is not like you cannot have both true. If this is true, true. If this is true, true. If both of them are true, it is still true. Is that okay? So using the two propositions we have, Kai is the lecturer of this course, and this course is held on Monday and Friday, then the disjunction or will be true. Okay. Okay, we know the first one is true, then we can forget about the next one. Very good. Okay, and then, so these are the three very basic logic operators. But we have one more. We call it exclusive or. Okay, now this is going to be the hints for the puzzle. I'll let you think about it at home. We can talk about this on Wednesday. Okay, yeah. So this exclusive or. So what is exclusive or? Usually, it is written with this symbol. So I have a P, a proposition P, I have a Q, then I can create something like P exclusive or Q. Exclusive or means that exactly one of them is true, then it is true. Exactly. If both of them are true, it is false. Is that okay? So it is going to differentiate with this disjunction. Disjunction is one of them true, okay. But here we need to have one of them true, one of them false. Okay? So using the same example, let's say the first sentence is Kai is the lecturer of this course. And then the second sentence, the second proposition is this course is held on Monday and Friday. After you read the first sentence, Kai is the lecturer of this course, you know that the disjunction or will be true. But still, at this moment, you don't know the exclusive or whether it is true or not. You have to listen to the next one. The next one says, okay, the course is on Monday and Friday, and you know that this is false. So one of them is true, one of them is false. So in the other case, this will be true. Is that okay? Okay. Now, the hints. Okay. So two things that I want you to try to think about it. One is, okay, now P is a proposition, Q is a proposition. We make a new one, P exclusive for Q. So this becomes a new proposition, right? We can also now talk about something like P exclusive for Q. So I get something. This is a proposition. And then I have another one, exclusive for R. Okay? Then you can talk about what is it. Okay? Now the first thing that I want to ask you is to check that this operator is very interesting. what is the true value of PQR? This one is always the same as this one. They are the same. Okay, so in that sense, this ordering of the bracket does not matter. We can do this two first and do this later. And then, or we can do this two first and do this later. So this is the first thing that I want to check at home. Now, the second one is, okay, if this is the case, then what does it mean? Okay, so it means that because the ordering does not matter, the ordering of this bracket, which one to be done first doesn't matter. So if you have a long, very long one, P exclusive for Q, exclusive for R, exclusive for S, exclusive for T, whatever, you have a long one, very, very long one, you don't need to write down the bracket at all, because let's say someone really wants something like this, but you know that you can rearrange the bracket and then do whatever you like. Maybe you can do this P or Q first, and then you do this R or S first, and then maybe you do this too, and then you do this exclusive for T. They should have the same result. Now, if the second question is, okay, this time it is about evaluation. So suppose that I tell you that this one is true, this one is true, this one is false, this one is true, this one is false. Can you quickly compute what is the answer of this one? Okay, is there a way to compute? Oh, really? Yes, true. Wow, quick, very quick. How do you get that? This is true. Yeah, this is true because, is it?
Yes.
Wow, you are very quick. Okay. Yeah, it takes me some time. Okay, I guess you are right. Okay. How about I change it to false? Okay. False. Okay, I change it to false. True. I change it to false. False. Okay. I change this back to true. True. Okay, good. Okay. This is the hint for the IQ question. Okay, see if you can come up with a solution that has 19 correct answers. Okay, thanks all. Okay.